Hi there and welcome to part 4 of this video tutorial series on Tidal cycles, a live coding language. Today we're going to be talking about a few more advanced ways of defining and manipulating patterns, both of sounds and also of effects. But first thing I want to mention is something I forgot to mention earlier, which was, well, say for example here I've got a simple pattern of two tabla tracks going at once. So say I've got that going there, and then on the second track I've got two notes, RP1 and RP2. And then on the third track, say I've got a hi-hat, 4 hi-hats. I mean, this is quite a very, very basic example, but you can imagine that you could have multiple things. You could have any amount of things happening at once. If I were to just want to listen to, if I was wanting just to reduce the listening to one track currently, it would be, say I wanted to reduce it just to the tablet. What I'd have to do is I have to do D2 silence, and then change 2 to 3 and run that, which is a bit of a pain. It's a bit of a long way around to doing it, and it isn't instant, especially if there are, say, nine tracks and I wanted to silence 8 of them. However, there is another way of doing it. So say I wanted just to hear this line here, the tablet line. If I were to type in before the D1, type in solo space $sign another space, if I were to run that there isolates just that D1 line. It does, however, mean that we need to reactivate D2 and D3 manually, but there is another method that allows further customizable ways of silencing multiple tracks at once or bringing multiple tracks at once. There is another method to do that, but it's a little more complicated and will be for another video. But that's just why the solo commands just wanted to briefly mention there. Now, one of the other things I wanted to mention is that so far what we've been doing is we've been defining the pattern by the sound, and then so here we've been defining the pattern on RP1, RP2. Actually, for simplicity's sake, we're just going to have RP1 times 4. So same pitch, and then what we've been doing is we've been then mapping various patterns for effects onto it. So say 0.5, 1.5, 1, 2. So there's the case that we're mapping this speed effect pattern onto the sound. But there is another way to do this, which is basically the exact opposite, and it involves essentially, well, instead of defining the pattern by the sound, we define the pattern by the effect. So let's, instead of doing it this way, let's do D2 again, except this time let's define the speed as 0.5, 1.5, 1, 2. So it's the same speed pattern, and then what we're doing is we're then mapping the sounds to that, and the sounds for that's going to be RP1, which is the exact same sound as this, except in this one we're not. If I then turn RP1 to RP1 times 8, it's not doing anything, because what it's doing is it's still mapping whatever we give it here in sound to the speed pattern. And if I was to do 1 times 2 here, or times 7 here, we then start affecting rhythm. So here we're actually defining the pattern, defining the rhythmical interest by the speed function, and more or less mapping the sounds to the predefined pattern and speed. Now if I were to then add things to the pattern of sound, say add a tabla, it's then applying the RP1 sound to these speed values here, the 0.5 times 2 and 1.5, and then it's then applying this tabla sound to the second half of the pattern. It's 1 times 2 and 2. So, and this isn't just the case with speed. You can define your pattern initially by any of the effects. So you can define it by gain, by vowel, by any of the effects, and then apply the sound pattern or apply any of the other effects, and sort of map them to the initial pattern that you defined either in speed or gain or whatever. Which is, I mean, it depends entirely on what you're looking to use it for. But if you're looking to use it more as a sort of sequencer, if you're using to, if the main thing that's going to be changing with yours is going to be the sort of, say you're not particularly interested in changing the sample you're using. Say you're mostly going to be using just this RP sample. Instead of having various sort of ways of writing out RP1 times 4, instead of having to write out RP1 times 2 RP, RP1 times 2 RP, you're just having to write that RP, and then you're actually defining the pattern based on the things that are actually changing. So it's good to know that. The other thing that's quite useful to know is that, well, let's do a more sort of traditional one here. Let's do it the old style. Now, as you see, they're using this hash symbol, which in this case is short for this here. So it's vertical line equals vertical line. And if I replace this with that, it's the exact same thing. Now, what this does is this line equals line, is this then takes whatever you've got here and applies this to it. But what it's saying is that basically it's saying the speed at which it plays back will equal, hence the equal sign will equal 0.5, 1.5, 1, 2. But it isn't just equal sign. You can use that. You can use plus, minus, the asterisk, which is multiplication, and the forward slash, which is divide. And what these would do is these will add whatever value you give it to the previous value that it had. Take away whatever value you give it to the previous value it had, multiply and divide. So say I have this pattern here. Now, if I were to instead change this equals to a plus, what it would do what I'll do is I'll make it equals again, speed 1. Okay, so what I'm doing here is I'm defining that the speed at which I want to play this is going to be 1, and then I'm saying for the pattern I want to add to the speed 0.5, 1.5, 1, then 2. So if I run just this on its own, it's that. But then once I add 0.5, 1.5, 1, 2, it's actually playing at 1.5, 2.5, 2, 3. And this means if I change this number, I can move this entire pattern up and down by that. Or I could do it the other way around. I could do 0.5, 1.5, 1, 2 there, and then say I'm adding 0 to it, so back to the original one, but then if I add 1, I'm moving that entire pattern up and down. It makes it a bit more sensible that way. But I can also take away, so it's a bit slower. Now it's getting worse because the speed is actually negative numbers. Obviously I can also take away negative 1, which is the same as adding 1. It's basic mathematics. But I can also multiply. I can multiply by 2. Or I can divide by 5. You know, you've got quite a bit of freedom with these, and then as well as that, on top of these, you can layer these up as many times as you want. So you can create quite dense layers of this, and then as well as that, you've also got obviously from, I think I mentioned this in the video before, but you can, by doing sort of polyrhythm approach to speed, you can have multiple sounds going at the same time. So say let's get rid of this line actually. So let's just hear it as it is. So say in this case we've got this sort of very quick melodic sequency sort of sound. I can then, now by adding to it, I'm not actually changing, I'm changing the actual numbers themselves, but the ratio between these numbers is changing significantly as well. Hence it's not got the same sort of melodic sort of sound. Hence, so if I take, it sounds quite different to the original, which is this one. But then if I were to multiply it by say 0.5, it's got the same sort of melodic interest. The ratios remain the same. And actually just putting up by octaves here. And this is just your basic sort of harmonic ratios here. But it's important to understand how it works in that if you multiply, then you're going to be, if you multiply these numbers, then the ratio between them is going to remain the same, whereas if you just add or subtract, then you're changing the ratio, but it depends entirely on the usage that you want, depends on what you want to do at the time. Now the other thing you can do, now all these examples have involved sort of predefining a pattern. I can obviously multiply this pattern, or I can divide it and it'll go through the pattern at different rates. But one of the things I've been unable to do so far is create something that's quite smooth. This is just rigidly going between this number to this number to this number, or well, rigidly going this number to this number and this number to this number. It's very rigid, and if we want to create a sort of fluid, sort of up and down, it would be extremely hard to do like this. But there is another way to do it, which is through essentially scaling. What you're essentially doing is you're taking your pattern and applying it to a scale. In this case, for simplicity's sake, I'm going to apply it to sine wave. So instead of having your inverted commas, we're just going to have brackets. Now I'm going to slow this down considerably to 20, because otherwise it would be going around once per cycle and be very, very hard to follow. So I'm going to slow this down using the slow function, but what we're going to use is Dalton scale, and then what you provide is you provide the lowest number it can go to, so which in this case says we want the speed to go down. This is the number that will apply to the lowest number the speed will go at, which is 0.5 in this case, and also the highest number, which says 4. And then want to say what sort of pattern to follow, which in this case is a sine. There's also saw waves, blue square waves, a whole bunch of different sort of patterns it can follow, but for simplicity's sake, let's do a sine wave. So if we run this, so it's taking this, and over a period of time, in this case slowed down by 20, it's following a sort of sine wave and scaling up from 0.5 to 4, then back down. Now we can also, this is where things get a bit wild and interesting, is that we can also, as well as having that as just a predefined thing, we can also have that as an addition. So if we predefine our speed as something similar to what we had before actually, so I'm going to create sort of multiple layers of things happening at once again. Bear with me a second. So if we so basically what we're doing now is we're actually applying this transformation. I'm going to make it multiplication instead. we're applying this transformation and taking whatever number we get from this between 0 and 5 to 0.5 to 4, and we're then multiplying that by this number here. So we're going to get this pattern, but it's going to be moving up and down at this rate between these numbers, and it's multiplying by that. So let's run that. And one thing I quite like to do with it at this stage is, when this is quite a slow pattern, it's not the fastest pattern in the world, but then if we were to then move this up, make it faster, say make it so that you can't really, it doesn't sound like a whole bunch of individual notes, it sounds sort of more solid. You can create some really quite interesting effects with that. And let's say this sort of scaling motion can be applied to any effect. This can be applied to your gains, could be applied, obviously can't really be applied to your vowels, because that's not really, I don't believe it can, but not in the traditional sense where you're defining the actual vowels it's going for, but this can be applied to pretty much any effect that you use, so I highly recommend playing about with that. Anyway, that's it for this video. Enjoy.